Assalamualaikum and a very good morning. Today we're going to discuss about equilibriums of a particle. So if you have a question like this, we need to, the question asks you to determine the force in each cable and the force F needed to hold the 4 kg lamp. So we need to find cable AB, cable AB, cable BC, cable CD, and also F. In order for us to solve this problem, we need to know if it is in equilibrium. It means that the particle is at rest or in constant velocity, which means the acceleration is equal to 0. So as a result, we can say that the resultant force is equal to 0. Okay, and also the component of the resultant Frx is equal to 0. Fry is equal to 0. If it is 2D, we only consider for, in this case, is x and y. Right, we can solve the problem using a rectangular component to get the AB, BC, CD, or F. So first thing that we need to consider is, right, because we have 2 points there or 2 particles here, which is C and also B. So we have the known information, which is the mass for the lamp. It's a 4 kg there. So you can calculate the weight by the mass times with the gravity. So you get the force or the weight for the lamp. So you can find AB and BC from there. So after we finish focusing or doing calculation that related with point B, then we can move to point C to get the remaining value that we want to find the CD and also CF. Okay, so we can start with point B first. So we put point B first. Okay, so we have point B. Okay, point B. We need to draw the FBD for the point B. Okay, so this is point B. And cable, it is in tension because we focus on point B. We have lamp here. Okay, so 4 times 9, 0.81. Okay, so you get the weight. Okay, and then we have cable AB with the triangle. Also with the angle 60 degree. And then we have for BC 30. Because we're discussing about particles, so we need to pay attention to the specific point or particle that we choose. Okay, so this is, we label with AB, and this one, this is BC. Alright, this is your FPD for point B, or particle B. So we can use rectangular component to solve the problem. Okay, if this is in Scala, okay, so we just write like this. Summation of fx equal to 0, right? So what we have here is the AB, okay, negative, AB cos 60 degree. Right, then we have positive, okay, positive BC cos 30 degree. Okay, so it is equal to 0. And for the summations of Fy equal to 0, we have the AB is positive, AB, okay, so we have AB positive 60, and for BC it will be negative BC sine 30 degree, and then we have the weight of the lamp. It will be negative 39.24 Newton equal to 0. So we solve this equation using simultaneous equation to get the value of B, to get the magnitude of AB and also BC. So when you have calculated the value, you will get that the AB is equal to 67.97 Newton, while for B is equal to 39.24 Newton. Okay, this is if you are using the rectangular component. You can also solve the problem using cos triangle. So it's up to you. But I'm going to show you how to solve this one by using cos triangle. Okay, if you want to solve the problem using cos triangle, of course you have to construct the triangle. Okay, so we construct the triangle. Okay, we have the W for the lamp, the width for the lamp, which equal to 39.24 Newton. Okay, and then we have the BC. Okay, this is the BC. So we have to connect head to tail if we are using the cos triangle method. Okay, so we connect the BC. Okay, BC. So we know that this is 30 degree. And then we connect with A. So this is AB. Okay, this is AB. This is AB. Okay, and this is for BC. You can see the arrow. Okay, this one downward. This one is upward. So we just rearrange back and connect all together, all the forces. Use head to tail, head to tail, head to tail. So we get this is okay. This is 60. This is also 60 here. So we know that we have angle for here is 30 degree. This is also 30 degree. And this one will be 120, 90 plus 30. So you get 120. So we rearrange back. We can use sine law. So AB Alright, so AB, oh wait, so we have AB divided by, we use sine law, sine 120 degree is equal to, okay, this one is BC, okay, BC, sine, or you can write like this. Okay, so BC, we go to AB is equal to the width of the lamp, 39.24 Newton divided by sine 30 degree is equal to BC sine 30 degree. So when you solve it, you will get that the AB is 67.97 Newton, and for BC you get, for BC you will get 39.24 Newton. Okay, 39.24 Newton. You get the same answer. Okay, but we use the triangle to solve the problem. The previous one we are using the rectangular component. Okay, after we have finished finding the AB and BC, we can move to point C. We do the equilibriums. We do the free body diagram at point C. Okay, so because we are focusing on particles, so we try to settle all the problem or do the analysis at point B, and then we move to point C. Okay, so of course we have to draw the FBD. Okay, so from point B, we already have the answer for force AB, which is 67.97 Newton, and for BC, it is 39.24 Newton. So I have shown you the method of using rectangular component, and the other one is using the triangle, the force triangle to be exact. Okay, so after we have find the information, and after we have done the analysis at point B, we are moving forward to point C. Okay, so you have to draw the FBD for the points or particle C. So we draw the FBD for point C or particle C. Okay, so the same thing, right? So, okay, we have C here, and then we have force F that we do not know. Okay, we do not know the CD, and because it is cable, we know it's always tension. So 30 degree, so CD. Okay, and then we have the CB. Okay, CB we have or BC we have calculate earlier using the particle B, and then you pay attention to the arrow that we draw for particle B in FPD for point C or particle B, and also with this one. Okay, so please make sure you compare correctly. Okay, see clearly that for point C, you will have the arrow is in inverse direction. Okay, with the previous one in FBD point B. Okay, so this one is 30 degree, and we know that the BC is 39.24 Newton. Again, we can also use rectangular component and force triangle. So I'm going to show you the first one, the rectangular components. So we use the summation of fx equal to 0. Then we get that. Okay. So here we put a CD. CD is a positive in the sense of the for the x component, CD cos 30 degree, and then you can see that the BC also have the x component, but it is in negative. Okay, it's negative, so negative BC cos 30 degree. So as you can see here, so F does not have the x component, so only 2, and because BC we already get earlier, which is 39.24 Newton. So we have the CD cos 30 degree is 39.24 Newton. Cos 30 degree, so equal to 0, you get the CD is equal to 39.24 Newton. That's it. That is for finding for CD. And the next one, to find the F, we have to use the summation of Fy equal to 0, because we know that we only have, we have only a Y component for the F. So we write that. Okay, so we have the positive for the CD. It's not cos. Yeah, it should be sine. Okay, CD should be okay. Sine 30 degree, and then we have the positive of BC sine 30 degree, and then we have negative F. That's it. Yeah, we have negative F, so it's equal to 0. Say you know that the sine 30 is 0.5. Okay, so we already have this one. Newton, okay, 0.5 plus 39.24 Newton, 0.5 is equal to F, and we can say that the F is also 39.24 Newton. Okay, that's it. So we have finished finding the force at A, B, B, C, the magnitude of A, B, B, C, C, D, and also F by using for this one we are using the rectangular component. Okay, the next one I'm going to show you how we solve how we find CD and F by using force triangle. Okay, so this one. Okay, so we erase all this. Okay, so So we have calculate the CD and also F by using the rectangular component. Okay, so you get the value is similar, right? This is 39.24 Newton. Okay, now, right, so we are going to use the force triangle. The force triangle. Remember that you have to connect head to tail, head to tail, head to tail for the FPD. So we start with the easiest one. So we start with the F because it's directly downward in a y direction. So we have here, then we have to connect with the, by right, we can see that we have to connect with the CD. Yeah, we have to connect with CD. So CD here, okay, we connect with the CD. Okay, we can see that the angle 30 here. So we know that this is 60 degree. And then we connect CD with the BC. BC because we know that 39 is 39.24 Newton. And the angle, you can see that, okay, here is 30 degree. So we know that this is 60. Okay, so overall we know that this is also 60 degree. So we have F here, CD, BC. Okay, so F and CD we do not know, and because we already have all the three angles, so it's very easy for us to solve the problem because we can use sine law. So we have the F over sine 60 degree is equal to BC over, okay, sine 60 degree, and you can see it's equal to CD sine 60 degree. Okay, so you can solve the problem. You can see that this one is quite easy. Okay, so BC, what's the BC? BC is 39.24 Newton. Okay, divided by sine 60 degree. So we know that the F is equal to 39.24 Newton. And when you do the same, you can get CD also 39.24 Newton. So it's verified. We have the same answer. So you don't have you don't do any careless mistake for the previous using rectangular component and this one. Okay. So as conclusion, when you want to solve a problem related to equilibrium of particle, make sure that when you use rectangular component, fx must equal to 0, fy must equal to 0. And if it is in 3D, so you have to consider the fz is equal to 0. And overall, the resultant force is equal to 0. Or we can say the summations of the force is equal to 0. So everything is equal to 0. Okay, so that we call it is in equilibrium. Okay, now you have two options if it is related to three forces. Okay, so you can solve using rectangular component, fx equal to 0, fy equal to 0, or you can also use if it is involved three forces, yeah, because we can connect all the three forces into triangle. So you have an option to do to use force triangle to solve the problem. So with that, okay, I hope that you understand completely. Okay, you learn on how to use these two methods. Okay, so you use the one that you are most comfortable, so that you are confident to get the answer. So with that, thank you very much. Good luck. Assalamualaikum.